Yes, once again. Awesome. So we're going to cover 4.10 and 4.11 today. And just in case you have not downloaded the documents that I keep telling you about every single Class Connect, I file transferred them one more time for you guys. If you already have them, you can just click no that you don't want to save them. But they are the ones that I keep telling you about for Unit 4 that are in doc sharing as well. So you can also grab them there. All right, so 4.10. Let me give you polling just in case some of you guys already know the answer. Go for it, or if you want to give it a shot before I get done talking, feel free to try and solve this. All right, so it says let segments AP, so we're looking at this picture down here, AP and BP, well, it could be this one as well, same picture really. Find the measure of the segment AP if AP equals 3x plus 10 centimeters and BP equals 8x minus 15 centimeters. So here's one thing that you'll find on that formula reference sheet. If you have two tangent segments and they intersect each other, then from the circle to the point of intersection, those two segments are going to be equal. So this one, if you realize that, is really pretty straightforward, right? Because it tells us that AP is 3x plus 10, and this one's 8x minus 15. And they're both tangent to the circle, and they meet at point P. So, yep, you got it, Will. All you have to do here is make them equal to each other. So as long as you make that geometry connection, the algebra part's pretty straightforward. So it's just an algebra problem. We're going to solve it. We could subtract 3x. We could add, oops, this is minus. I was going to say we could add 15, but then I put the plus in the wrong spot there. Okay, so we'd have 25 equals 5x divide by 5, and x would equal 5. Now, is that the answer? Well, let's double check. What do we want to find? Because I see some A's. They're doing that trick they always do to you in this class, aren't they? They don't want X, they want segment AP. So be careful. You gotta plug X back in. You gotta do 3 times 5 plus 10. So it'd be 15 plus 10. There we go. I see some of those answers changing. D looks better, right? So just be careful. They do that to you all the time in this class, don't they? So, yes, I know, Brian. I know, because I know a lot of times it gets you guys, but just fair warning in this class, you got to remember to go back and read the directions and make sure you found the right thing. All right, here's another formula. Again, it's on that formula sheet. So if you have two chords and they intersect each other, here's a little equation that sometimes comes in handy. You're taking each piece of the chord. So we have chord AB. It is broken into two pieces, A, E, and EB. So you're going to take those two pieces and multiply them, and that's going to be equal to the other chords pieces. So we have chord CD that's intersecting chord AB. If we take CE and ED and multiply, then that's going to be equal to the other two pieces multiplied together. Okay. Oh, 12. Oh, yeah, well, okay. So you okay, so don't choose A and D, one or the other. You're right there, Ravi. That's I need to fix that, don't I? Okay, so it says find the value of x. So in this case, we are looking for x. If AE is x plus 2, so let's put this, I always think it's helpful if you can put it on that picture. So this is x plus 2, EB is 8, CE is 3x, and ED is 4. So according to this equation, we would take x plus 2 times 8. That would be the two sections that chord AB is divided into. Okay, that's true. Let's cross out D. Okay, and then we would take CE and ED and multiply. Okay, so I'm just using this equation right here. I took AB and EB and multiplied here, and CE and ED and multiplied here. Any questions on how I got to this part? Do you guys see how to plug everything in? Okay. Looks good. Okay. Now, that's the geometry. You're done with the geometry part. If you have trouble from here, blame it on Algebra 1. Okay, so again, here what you want to do, I know usually we write the 8 in front, which you're welcome to do, but you want to multiply because you have an addition sign here. You're going to distribute the 8 in. So you should end up with 8x plus 16. And then over here, there's no addition sign, so just multiplying those together would give you 12x. Okay. Yep, looks good, Yusuf. And so then we're going to subtract 8x. So that's one thing you could do anyway. And then x would end up being 4. And are we done? In this case, yes. It just says find the value of x. So the 12s didn't matter in this one, right? Even though I had them on there twice. Makes you seem like that might be the right answer. Oh, really, Stephanie? Oh, that's not good. Were any of the rest of you guys having trouble with Blackboard? Just a warning, I guess, whether we're going to have trouble today or not. Sometimes there are days like that. Nope. Okay. Yes, it definitely can, Will. Oh, no, and now Stephanie got kicked out. She's definitely having trouble. That is not good. All right, let's take a look at this one. Here's the formula you want to use down here. Okay, anybody want to give this one a shot on the whiteboard? See if you can apply it to this information. All right, we'll go for it. I'm going to give you whiteboard privilege. There you go. Okay, beautiful. Will is doing an excellent job down here. Nice work. Now, I know it's a little easier here because I used the same picture as is in this formula, but let's take a look at the breakdown of the formula while Will is completing it. You can, if you notice here, segment AC is a secant, okay, which is just a chord that extends past. So a chord would end on each, the endpoints around the circle. A segment extends outside of it, okay? So this is kind of the gist of the formula. You're going to take the whole secant line, so from A to C, in other words, times just the outer portion, the part that's outside of the circle, which is BC, and then it's equal to the same pattern on the other secant line. So the whole secant line times just the outside portion. Okay, so this one is kind of in general how you would apply it if you don't have, you know, these specific letters. Apply it to the picture that you have. Okay, yep, and we're looking for X. So we got 2. Okay, so a few of you guys got a chance to beat Will to the punch and get it in there, at least work along with him. For those of you that didn't quite have your answer in polling, does it make sense? Are there any questions here about how Will completed that? Thank you for doing that, Will. Give Will a round of applause. Nice job. Makes sense to everybody? Okay. Perfect. All right. Here's another formula that's similar to the last one, except the difference here is that you have one line that's a tangent line, and the other is a secant line. Okay, so here's the general pattern. Anyone want to try this one out? Maybe besides Will. I know I love it that Will volunteers, but okay, Ben. There you go, Ben. Go for it. And you guys, if you can, try and beat him. Okay. So you have the whole, now this side, the left side applies to the tangent line. So BC is your tangent line. Let's write that up here, just so you know. So this is the tangent side. And you're just going to square the tangent because it's the part outside of the circle. And then the EC is your secant line. Okay? So with the secant side, you're going to take the whole secant line from E to C and multiply it by BC, which is that outer part, the part outside the circle. Questions about how to apply that formula? I think what starts to get confusing now that we're getting to the end of Unit 4, so through this week you're actually going to have learned everything in Unit 4, and then next week is going to be your Unit 4 test, and then we have one more unit and you're done this year. So Unit 5 is going to be our last one besides the final. But I think what gets hard here in Unit 4 is knowing, okay, well here's a formula, and the formula itself isn't that confusing. But how do you know when to use the formula? I think gets tricky because there's so much stuff on those formula sheets. We have a ton of information in Unit 4. So that's what I'm trying to point out to you guys. This is when you would use it, is if you have a picture with a tangent line and a secant line. Then that's when you can apply this formula. Okay? Oh, don't stress about that, Ben. Yeah, that's perfectly fine for a square root. Those are difficult. Now you could probably, do you guys remember, just kind of a side note, how, like if you had multiple choice answers here, how could you estimate that? So if you had multiple choice answers, how would you, or even if you didn't have multiple choice and you kind of had to give an estimate, yeah, you could take the answers and square them, right? So you could say 7 times 7 is 49. Well, that's a little bit low. 9 times 9, 81. That's a little bit high. So it has to be between 7 and 9 somewhere. Yeah, and then, well, Ben's right. Yes. Oh, you're saying, no, yeah, you're right, Ben. You're right. 7.7, I was saying if you didn't have multiple choice, you could start with whole numbers. But yes, since you have advantage of a calculator, or even if you didn't have a calculator, you could say, well, 7 times 7 is too small, 7.9 is too big, so probably 7.7 would be just about right, you know, because it's in between 7 and 9. But yes, so D, since we have use of the calculator here, we can get it to the nearest tenth at least. So yes, very nice. Give them a round of applause. Beautiful job. Any questions on that one? Does it make sense to you guys where you would use this? So this formula is nice, but it only helps if you know when to use it, right? So that's the challenge in Unit 4. Okay, so just try to pay attention to that. And as you look at that very long formula sheet, say, okay, well, when would I use this one? When would I use this one? And kind of study before the test in that way. Like challenge yourself to say, okay, when would I know when to use this? I know I get the formula, but how do I know when this formula is valid? Okay. Yes, and I would challenge you guys to learn as many of those formulas as you can, because PARCC testing is coming up again. So this year, you know, is different. We had state testing in March, and then you're going to have it again at the end of the year. And from what I've seen, you probably will see a lot of Unit 4 and Unit 5 on there. So I know, like I said, we haven't gotten to Unit 5 yet, but Unit 5 is a lot of trig stuff. And if you plan to go on in math, Unit 5 is going to be very important to you. So whether you do it for state testing or not, just really absorb Unit 5 because you're going to see it in Algebra 2, you're going to see it in pre-calc, you're going to see it in calc, you're going to, keep going. So, no, Unit 5, we changed gears. So Unit 5, you guys remember sine, cosine, and tangent? Trigonometry stuff. Yes. So you should have seen that already. Oh, I don't know, Tristan. I don't think it's exactly the same. I'm not sure. It's the first year they've done it, and they don't tell us all that stuff because we're not supposed to know, which I don't know. It's kind of crazy. Yeah. That's a good way to put it, Tristan. We do have sample tests, but as far as knowing exactly the details, like, is the March test going to look exactly like the end of the year test? I would guess probably not, but I'm not sure. No, Will, actually, that's what I'm saying. We're going to hit that in Unit 5. Yes. So Unit 5 is all about sine, cosine, tangents. We're going to learn, you probably remember SOHCAHTOA. You guys remember that? Give me a smiley face if that sounds familiar. If not, it's going to real soon. We're going to hit that in Unit 5. It's just a way to remember the trig ratios. Okay. So maybe some of you guys, it looks like you didn't hit it too hard in Algebra 1. So we usually do that in Algebra 1, and then you see it in Geometry, Algebra 2, Pre-Calc, in every math class after that. But yes, you'll learn that here in Unit 5. But for now, focus on Unit 4. We're actually done for today. Can you believe it? We ended it way early. 4.10 and 4.11 are pretty short and sweet. Again, the main thing, we went over the formula. The formulas you need, you just have to know when to use them. Yeah, yes, Tristan, now we can take a nap, right? Yes. So like I said, this week I'm going to be out Tuesday and Thursday, so I won't have my usual tutor times, but we'll have Class Connects. I will be in on Wednesday and Friday. So if you do end up with any questions, let me know. Send me a K-mail if it's Tuesday or Thursday. Oh, yes, I will. Sorry, Stephanie, you kept getting kicked out there. But yes, we just had 6 slides today, and we are done. So nice job today. I hope that it's pretty straightforward, but I'll hang out for a few minutes if anyone has any questions, okay?